Hello, my name is Ana Maria Guzgan, and I would like to present the BIM solutions for full parametric infrastructure projects and how this approach influences the workflow across all stages of the project. This presentation was made in collaboration with my colleague Adrian Ghencea. The paper presents an overview of the world's first complete solution that provides reliable design, time and cost data for infrastructure projects. Accelerate development and deployment of innovative technologies are the main objectives for all major projects, starting from buildings, offices, to roads, highways, railways, and bridges. In a rapid changing industry, the implementation of BIM in a company's workflow and projects leads to obvious benefits. Everyone involved in the project has access to the latest design. The digital models are highly detailed, and BIM coordination happens interactively on the digital bridge model. Bridge design presents unique challenges that have typically been difficult for existing technologies to address, but this is changing. Innovative new bridge design software is making BIM for bridge design easier, as well as more efficient and cost-effective. Allplan Bridge is the professional BIM solution for bridge construction. Why use parametric solutions? Information is linked via algorithm in a digital parametric structured model so that when a change is made, components are updated automatically in line with specified parameters. The parametric model can be reused and further developed from project to project. Allplan Bridge, the world's first full solution for bridges, along with Allplan and the cloud-based BIM platform BIM+, are parametric solutions with powerful functionalities that helps us create parametric projects. One of the biggest benefits of this round trip is a common data environment. This means that the parametric model contains all relevant project data, accessible by everyone in one centralized location in real time. Eliminates the needs for progress updates to each of the different disciplines working on the same project every time a change is made. It's key to understand that BIM is so much more than just a 3D rendering of the structure. It's a digital working method that is based on virtual 3D models. 3D infrastructure models are built to digitally display design information, such as technical drawings, plans, elevations, for infrastructure projects compared to traditional design, construction, and facility management processes. For example, GIS can be combined with geotechnical information to help identify the preferred route for a tunnel that avoids difficult geotechnical conditions, and BIM can help engineers visually explore project execution, manage project costs more effectively, and better predict project outcomes. So, when we say Allplan Bridge, we refer to modeling, pre-stressing, and structural analysis. The parametric bridge model, including pre-stressing tendons and construction sequence definition, offers a high level of flexibility. After finishing the planning in Allplan Bridge, we can deliver the information in Allplan for reinforcement, detailing, views, or sections. Besides that, the analytical model generated in Allplan Bridge can be uploaded to the cloud-based BIM platform Allplan BIM+, and if changes are made to the framework conditions, the components of a design are automatically updated using parametric BIM modeling approach. For the BIM method to work, a shared central model is required, which all project team members can access. Working on several different models is difficult enough without the added complexity of sharing and coordinating each model with a central BIM model. And here it stands Allplan Bridge, this unique solution that uses only one model for 4D parametric modeling and structural analysis. The entire team can access our parametric solution, and with Allplan Bridge, different loading scenarios can be analyzed whether for the initial design or the construction stage, all within one model. This powerful solution has been specifically developed for the parametric modeling of bridges. The initial focus points were on the requirements of detailing concrete and composite bridges, but now it is possible to model any kind of bridges. First step, when we start working with Adrian bridge, is modeling. For example, the user only needs to define one typical cross-section, and Adrian bridge will calculate all cross-section variants in accordance with the defined table or formulas. Once the construction is completed in Adrian bridge, the model is transferred to Adrian, where further steps are carried out. Additional modeling approach specialized for precast girder bridges is now available. The original parametric modeling approach is based on geometries following a road or a bridge axis, but for precast girder bridges, the geometry of a superstructure is not governed by the geometry of the axis, but rather by the geometry of a substructure and its position along the axis. A stressing sequence can be defined for each tendon specified in the model. Stressing, wedge slip, and releasing are available actions. The analytical model is generated from the geometrical one. Additional loads, such as temperature changes or wind loads, can also be easily defined and applied. Using the theory of influence lines, Adrian bridge can quickly and easily determine the most unfavorable effects due to traffic loads. Adrian bridge analyzes the defined construction schedule and sets up all necessary calculation definitions in an automated process, like load cases, element activations, and calculation actions. Uses the multi-mode response spectrum method for evaluating the effects of seismic loading. The definition and visualization of combinations in table form provides the user with an overview of not only the defined load factors, but also the various types of combinations. By simply specifying the construction process, time as a fourth dimension is taken into account. The construction plan can also be divided into phases, which are further subdivided into individual tasks. Adrian bridge offers the option of placing intelligent objects, which are automatically aligned and adapted each time the bridge geometry is changed. You can see how easy it is to add a Python part in our bridge structure. Parametric objects, so-called Python parts, are placed at predefined properties with the correct alignment and predefined parameters. This speeds up the generation of a detailed bridge model, including reinforcement if necessary. On the left side, you can see how quickly we can add Python parts in Adrian bridge, and on the right side, you can see the updated model in Adrian. We can also place reinforcement piles, elements that have intelligent attributes and parameters. The digital bridge model is used to generate elevations, longitudinal sections, and transversal ones. To create high-quality construction documentation, Adrian's powerful layout and design tools are used. Reports with dimensions, areas, volumes, and quantities are available at the touch of the button. In BIM processes, 3D modeling and a data management platform have been proven benefits for the design process. However, BIM Plus also provides advantages for the construction phase. Even before construction begins, contractors can be invited to the project and assist with the design and planning thanks to the visualization and information management that BIM Plus enables. With an easy access to the model and any information required, we can save time and money. Adrian BIM Plus goes beyond the common data environment functionality, putting the model in the center of collaboration. This approach is key to making construction planning and implementation more efficient. In other words, BIM Plus simply enables data to be managed for better construction. IFC Bridge became an official project in Building Smart in October 2016 and was initiated following the IFC alignment work. Has been extended with new definitions with IFC 4.3 that includes now bridges, roads, and rails in order to better explain and rationally define the specific details related to the objects in infrastructure sector. This standard for data exchange is supported by both Allplan and Allplan Bridge. Bridge type and bridge part type are used with enhanced objects types to represent respective bridge elements. Practice has shown IFC and open BIM thinking are firmly anchored in planning. This being said, I want to thank you for attending my presentation today and to encourage you all to get started for free with Allplan and Allplan Bridge and work on your infrastructures projects.